Test 1, 2, 1, 2, 1. Or testing mic 1, 2, 3, 4. 1, 2, 3, 4. Test mic 1, 2, 3, 4. Testing 1, 2, 3, 4. Testing mic 1, 2, 3, 4. Mic 1, 2. Tengok dekat Zoom, dekat Imatet. Mic 1, 2, 4. Okay.
I check.
Tes. Bahan suara 1, 2. 5, 6, 7, 8. Quite okay. Okay, kita adjust. Not to block the.
Itu macam tak macam tu lagi. Dari sini. Contoh ada. Because the 有没有分布？
This one must stop for a while. Okay, already made it.
Okay. And also the speaker, we don't want the speaker out from here.
Okay.
We only have input, yeah. Okay.
No, but
You can hear? Can hear? Yeah. That's how we are. Okay. No, when I have video that time, I must speak to here. You still can hear me, right? Yeah, from computer. Yeah. Okay, can you hear me? Boleh dengar? Okay.
Hello. Is this Gordon's Pizza?
Can you hear
No,
me?
sir. It's
Can,
Google's Pizza.
Yeah, okay.
Did I die?
Very clear. Okay, I mute already. That's why.
Can you say right now? Can you speak?
Can you hear? Okay, yeah. I share. There's an echo because of anything else. Okay. Okay. Yeah. Okay, I play the video as well. Yeah. And you can hear me? Video cannot hear?
Did you share the screen?
Already share the screen, already share. Wait, open.
I stopped. Microphone. Okay, same. Okay, try again. Can you hear the video? Can you hear the video? Hmm? It's correct. Just now also do the same thing.
No video.
Oh, because I have to share first.
Yes. You have to share first.
You know what my
Okay, now can you hear?
According to the caller ID, the last 15 times you've
Okay, here
eaten a
video as
12
well.
slice with
Everything
double
okay, yeah?
cheese,
Okay, okay.
sausage, and thick
Thanks.
crust.
Okay.
So I start share screen.
Okay, yeah?
Dah.
So everything okay.
Cuma dalam bilik ni akan jadi senyap.
Tapi nanti dia cakap on balik.
Cakap sebab dah ada.
Dia akan pakai headset sampai ni lah.
I think all the time I just use this one lah. Yeah, headset. I just use the headset all the time.
You use headset only when you want to play the video.
Video. But I think we can test
Dia
it.
play headset bila dia nak buka video je kan?
But we can test this one. If we play using this one, I think not so clear.
No, echo.
Echo.
Yes.
So if I'm doing presentation normal the time, even we use this one, it's not so clear.
Use this one.
Use this one.
Sound.
Okay, so we
clearer
test
than
it.
your laptop.
We test it. See which one is clear.
We already test.
Ah.
We cannot test this one.
Really?
Yes, we already test. No worry.
Sure, clear.
We can test
The sound.
Just try to speak and we see.
Okay.
Cuma
So,
pakai tu. Sekejap.
Okay.
Siapa kena dengar balik. Tapi nanti you kena pakai headset. Tak cantik lah. Okay, start.
Can you hear me? Testing. 1, 2, 3, 10. Can you hear me clear? No echo sound.
Okay, loud and clear.
Okay, good. Thanks.
Okay, so we use the
Okay.
headset
just
only
switch.
for video,
Yeah.
and then we switch to the speaker.
Yeah. Okay.
You share video tu, mic tu dia akan connect kan. Kita boleh share video lagi sekali sambil.
What we can do is when we share the time, when I need to, then I mute and unmute. Actually, when I do the video, I need to stop. I let them watch finish, I stop. So I don't even need this one. We test it without this one, and just off it while we do the video.
Sure.
After we finish, we on it and I share it. Yeah. Okay, we try again. So Saya tak dengar. It's okay. I don't need to hear.
This one need to open.
I can hear through here.
Okay.
Can hear? Okay. Zoom, actually, I must. I should not share the sound first. I mute. How come I mute still got echo sound? Why is it echo? The echo because. Oh, okay. Okay, can hear? No problem, huh? Okay, so I now want to share the video. So what I do is I have to unmute. Can hear?
Tak share screen.
Oh.
Okay.
How to go to Zoom?
Escape.
Zoom is.
Okay. I will
have to share the screen.
Okay. Okay, sharing. Here. In here? Because this sound must on for them.
All right, then I'd like to place an order, please.
Okay, sir.
What my usual is.
According to the caller ID, the last 15 times you ordered a 12 slice with double cheese, sausage, and thick crust.
So after that,
Okay,
I have
that's
to
what I want this time too.
mute it.
May I suggest
And then we
that
have
this
to turn
time
this
you
on
order
on.
an 8 slice with
This,
ricotta,
press this one,
arugula, and
this one,
tomato instead?
on off.
No,
So I just
I
enter,
hate vegetables.
But your cholesterol is not good.
How do you know?
Through the subscriber's guide, we have the results of your blood tests for the last 7 years.
Maybe so, but I don't want the pizza you suggest. I already take.
This one is blue color is on.
If let's say time's up. Okay, Assalamualaikum dan selamat pagi. Saya harap semua dapat dengar suara saya ya. Okay, so kalau tak ada di chat tu maksudnya boleh dengar lah kot. Okay, selamat datang ke kita webinar Intan pada hari ini. Creating value to big data analytics. Okay, Alhamdulillah dengar bagus Cik Muhammad. Okay, so untuk pagi ni sebelum kita mulakan webinar kita, saya bagi pihak Setia ingin memohon 1000 kemaafan ya atas isu teknikal pada pendaftaran pada pagi ni yang kita tidak jangka, tapi tuan-tuan dan puan-puan masih boleh mendaftar melalui link yang kita paste dekat chat. From time to time kita akan paste dekat chat. Dan kalau ada masalah untuk mendaftar, boleh connect chat directly dengan kita punya Setia lah. Okay. So sebelum kita mula beberapa perkara yang perlu kita ambil maklum. Of course, perkara pertama sekali ialah kalau ada some technical glitch atau isu teknikal, harap dapat bersabarlah. Okay. Dan yang kedua, kalau ada any Q&A, kita akan ada sesi Q&A nanti. Tapi kalau nak bertanya soalan, boleh masukkan dekat chat ni soalan tuan-tuan dan puan-puan. Dan kita akan jawab semasa penceramah akan jawab semasa sesi Q&A ya. Okey, untuk webinar kita pada hari ini, kita ada penceramah daripada syarikat Speed Miners dan Berhad, Mr. Thomas Howe. So later on Encik Thomas akan introduce himself ya. So okay, before that saya sedikit introduction untuk webinar ni. Kenapa kita buat webinar ni is actually first thing first ialah kita nak adaptasi new normal sebab kita sekarang ni dalam tempoh PKP. So ya, kita masih boleh lagi menyampaikan maklumat mengenai trend teknologi digital walaupun kita dalam keadaan maya lah. Cuma mungkin ada sedikit isu connection tu kita tak dapat elakkan lah. So okay, untuk webinar kita pada hari ini, kita akan menampilkan perkongsian ilmu pengetahuan mengenai data raya ataupun big data untuk kita memperkukuhkan lagi pengurusan maklumat di agensi masing-masing. Okay, so without further ado, saya serahkan kepada penceramah kita, Encik Thomas Howe. So kalau tuan-tuan dan puan-puan boleh tengok di skrin, Mr. Thomas Howe ada 28 years of experience in ICT industry. So seorang yang pakar dalam, ada banyak pengalaman dan juga kepakaran dalam bidang ICT lah. Okay. So tanpa melengahkan masa, saya serahkan kepada Encik Thomas Howe. Okay, over to you Mr. Thomas.
Okay, thank you Puan. Thanks to Intan for organizing this webinar, and very good morning to all the participants. So as introduced, my name is Thomas. Okay, as mentioned, I will introduce about myself. I think the slides earlier already outlined my experience in the past. So I've been working as a data scientist in the field of big data for many years, actually, since early time before we coined the term of big data. We already start the implementation of the big data. Okay, today, the agenda, the first session, we will have 30 minutes to talk about the big data use case. And after that, we follow by the quiz and the break. At about 10 o'clock, we will start another session, which talk about the implementation of the big data. In this second session, I will showcase to you the tools, the tools that we use to build the big data solutions together with the analysis and analytics. And the last session, we will have the unstructured data analytics. So a lot of people talk about the predictive modeling, which is on the structured data. So I would like to touch base on unstructured data analytics at the end as well. Okay. So let's start our first session with a video.
Hello. Is this Gord? Gordon's Pizza?
No sir, it's Google's Pizza.
Did I dial the wrong number?
No sir, Google bought the pizza store.
Oh, alright, then I'd like to place an order please.
Okay sir, do you want the usual?
The usual? You know what my usual is?
According to the caller ID, the last 15 times you've ordered a 12 slice with double cheese, sausage, and thick crust.
Okay, that's what I want this time too.
May I suggest that this time you order an 8 slice with ricotta, arugula, and tomato instead?
No, I hate vegetables.
But your cholesterol is not good.
How do you know?
Through the subscriber's guide. We have the results of your blood tests for the last 7 years.
Maybe so, but I don't want the pizza you suggest. I already take medicine for high cholesterol.
But you haven't taken the medicine regularly. 4 months ago you purchased from Drug Sale Network a box of only 30 tablets.
I bought more from another drugstore.
It's not showing on your credit card, sir.
I paid in cash.
But according to your bank statement you did not withdraw that much cash.
I have another source of cash.
This is not showing on your last tax form, unless you got it from an undeclared income source.
To hell with your pizza. Enough. I'm sick of Google, Facebook, Twitter, and WhatsApp. I'm going to an island without internet, where there's no cell phone line, and no one to spy on me.
I understand, sir, but you will need to renew your passport. It expired 5 weeks ago.
Okay, this is more of a joke, yeah. Okay, sorry, hopefully you're back here. More of a joke to wake everybody up in the morning. The next things we want to talk about is the big data, yeah. The big data is more about prediction. Of course, some may disagree because there are other things besides prediction, but for now, we just deal with about prediction, yeah. So there are a lot of government agencies like Japan, they want to predict about the property value. Besides their traditional methods to do valuation, there are also a big data approach to do a property valuation. Like for example, Jabatan Pengarelan Air, JPA, they also want to predict about the dam level, for example, so that we ensure that we have enough water, or we know in advance whether we have a shortage of water. Tourism Malaysia, they would like to predict about the number of visitors coming to Malaysia. If we see that this trend is moving downwards, probably want to organize some event in the countries, in certain countries, to promote our tourism. Yeah. So on the university side, they also want to predict whether the students will drop out from the course, yeah, whether they will pass the exam, can complete the course in time. All these are about prediction. All these are what big data can assist the organization to be more prepared, yeah, for what is to come. Okay, just a very brief slides to talk about the big data prediction, because business intelligence also do prediction, but the business intelligence prediction is based on trending. For example, we talk about the property sales. I don't know the value, I just make it up, the figures. So if we do not know the figures for 2020 yet, from the graph, we will probably expect the trend to move up to 14 trillion. So that's what a normal prediction will do based on the trending. But if we are presented with additional information like the foreign direct investment that have influence or what we call a coloration in statistics, with the total sales, the property sales, then we can estimate for this 2020 to drop because the FDI also dropped last year because our graph up to 2019 doesn't show the economic situation due to the COVID-19 pandemic. So with that additional information now, we may make our decision slightly different. So what I want to stress is that the big data doesn't look at trend alone. You also look at the other factors that influence what we want to predict. So what we want to predict is the outcome. Okay, what qualifies to call a big data? There are a few areas must be present here. First, we need an algorithm that is called a machine learning algorithm. So for different type of problem, we will use different algorithm. So some of the data that is more linear in relationship, like if you plot it out, it will be a straight line. So we call it a linear regression. So we will use a certain formula. If we want to predict a picture, whether it's a dog or a cat, then we will use something called neural network because that mimic our brain. So algorithm learns. All this machine learning algorithm, they start with zero knowledge about the environment we are in. So for example, if you want to make the computer to understand the words apple, so there are many meanings about this apple. It can be an apple computer. It can be the apple that we eat, the fruits. So to make the computer be able to analyze when we speak the words apple, what we do is we can send the computer program, the machine learning, to two websites. The first website is about the Wikipedia apple. So when they go to Wikipedia apple, they learn about the fruits called apple. And we also send the program to the website for the Apple Inc. to learn about the computer, Apple computer. So if after learning, we can type a question to the computer, say that I bought an apple yesterday from the market. So the computer will, from the sentence, guess whether I'm talking about the fruits or I'm talking about the computer company. So because a stock market is also market, and you go to the market to buy the apple, the fruits, and so it's also a market. So computer may be a little bit confused, but if let's say you add a sentence to say it was delicious, then the computer straight away will know that this is about the fruits because you already learned to associate the delicious, the words delicious to the fruits, apple. Okay, so that's how computer learn. Okay. We also feed the data for algorithm to learn. So the website that I just mentioned, or the historical data, all these are the training data to make the machine learning to learn so that they are more able to tell the situation that we are in. So another example is waste. The ways that you use every day, you have to learn the traffic in KL, for example. Okay, so when we ask a new questions, the prediction can give an answer after learning. Okay, give you two examples. The first example is voice to text. Of course, the new generation voice to text. You don't have to train the program anymore. But the old day voice to text, the process is using like a big data algorithm. So you have to speak. They will give you a text article that you have to read to the program. So the program get used to your voice, your pronunciation, and be able to do a better prediction. So this is the learning stage the computer need to go through. Okay, this is supervised learning. Supervised learning is something that we let the computer to learn, and we tell them what is the outcome or what is the result. Yeah. So if let's say we provide the ways to learn, and the ways will need the input about the weather condition to be a smarter, be able to tell the traffic condition and so on, the time of the day, whether today is a holiday. All these are what we call the input to make the ways smarter. So everyone of us use Waze before. We hope that the Waze program can be smarter through the machine learning. So if the writer of this Waze adds the intelligence to it to learn all these other factors, which is what we call predictors, then they can predict the outcome better. The outcome is how long to reach home. I give a few other examples about this prediction. Yeah. Another example of the supervised learning is we want to predict about the property. So throughout this session, later on, I will talk a lot about the property because it's something quite common. So to learn from the past sales experience, the computer program, the machine learning will pick up the predictors or what we use to predict, which is example like land size, the built-up area, and so on. And then what do we want to predict? What we want to predict is the outcome. The outcome is the value of the property. So after the machine learning, trained by all the past sales transaction, now you can ask the computer program, how much is my property worth? How much can I sell it? Yeah. So this is what the prediction can help us. So as we can see, the machine learning, the big data, is not something out of the box that you can straight away use it. You need to provide training. Okay. For example, the Waze program used in US, when you come to Malaysia, you have to start learning about the KL traffic. Otherwise, you will not be accurate. Okay, just now we talked about the supervised learning. There's another aspect of the big data called unsupervised learning. So unsupervised learning is something that will make the machine learning straight away dive in with a pool of data to find unknown patterns. So for example, we provide a lot of our customer data and let the computer auto group the customer. Let's say I hire 4 salespersons. I want to group all the data and let the 4 salesperson deal with the customers. So the computer have no idea what they want to do. They just try to find patterns to group them. After they group them, we might find something interesting. Certain group of customer that put together, there seems to be a high spending customers. They seems to like certain type of products. Yeah. So from there, we learn about the customers. Yeah. Another example of unsupervised learning is the recommender system. We all been to the website to buy glossary as well as buy books. Yeah. So Amazon.com, after you log in, they'll recommend you, I think you may like this book. Okay. So this is something that you cannot supervise to learn. There is no outcome. There's no right or wrong. It can't be recommend you a book and it said wrong. You recommend me a book that I don't like. Yeah, it's not about right or wrong. Yeah, it's about what they believe you might be interested. So the whole algorithm behind is slightly different. Yeah. So for example, this is a prison. Prison, they also want to detect whether a person is trying to commit suicide, self-harm, we call it. Yeah. So what we do is that through the video, we analyze, everybody move around and do their things, If they detect someone doing things out of the norm, different from others, then they would like to alert. This person may trying to do something to harm themselves, for example. If, for example, this case we want to do a machine learning, it's also impossible because how many cases we have where people try to commit suicide in prisons? There's not many, not enough information for the computer to learn and to understand the pattern. And the patterns can be varied. So best is to use unsupervised learning because that can just point out something different. Okay, so we back to the supervised learning. How the prediction come about. First, we have the data coming in, and then we cleanse the data. And then the next thing is to select the features. Okay, select the features means that you pick what is relevant because you may have a lot of data. Some is relevant, some is not relevant. Okay, so I stop here and let's go to the next slides. Later on, in this the second session and third session, it will be a lot of graphical dashboards, auto that we will showcase on the big data. And the data that we'll use is this property data that I show on the screen here. We have manually entered thousands of these transactions from the internet on this property, and we'll do a prediction. So we can see there are many columns of informations. A lot of time we have even more informations, but what are the factors or what are the variables or what are the predictors? Predictors is those columns that we can use to predict the price. So out of so many things, to select them is difficult things. So what we do is we normally use a computer to check the coloration. For example, we want to predict the price. So we can see that the other factors as compared to the price or correlate to the price, what is the relationship? One is perfect relationship. Okay, build up is 0.81, like that means there is a 81% chance of explaining the price. As we move down, we can see, because I saw it in the order, we move down all the way down to like jogging track, which have very little coloration. Okay, so we tend to select in a project, we tend to select those that are highly colorated to do the analysis. But it's not always the case because, for example, when the build-up is bigger, our bathroom, number of bathroom or number of rooms will tend to be more. So the number of rooms and number of bathroom may not explain more information or may not give more hints to the price, because once we have the build up, probably is enough. So there are other consideration factors. Another thing we normally do is to plot a graph between the price and the variable and to see their coloration, whether it is in the linear or what relationship. So from there, we can decide what algorithm to use as well. Okay, so we come back to here. So just now we mentioned that about this feature engineering. After we get the features of what we want to use to predict, we will start to break the data into two sets. One set is to train the machine, train the model. Okay, as you can see, this learning algorithm is coming in. We have to pick the right learning algorithm, the prediction algorithm as well. Using a wrong algorithm, the accuracy may not be as good. So after the model been trained, then we take the testing data to test our model again. This testing data never exposed to the algorithm before, so it's a fair testing to score for the scoring of the model. So after the scoring, we can tell whether this model is suitable to be used for big data prediction. Okay. Next, we want to see how to make a good prediction model. Yeah. So we have gone through the training. So now the system use this prediction to draw a line. This is the line for prediction. So if you want to do any prediction, even visually, we can see, if let's say 2,000 square feet, I can guess the value is probably about 1.over million. Okay. Why is this line towards the end have a wider range? Yeah. That is because you see those property below 5,000 square feet, we have many examples. So the computer, after learning, they are very comfortable to make accurate prediction. When you ask about 2,000 square feet, they're very sure to tell you it's 1.1 million. Yeah. But if you ask the questions about the property that is 30,000 square feet, the computer said that I don't have many examples at this 30,000 square feet. Therefore, I can only guess a range. So it could be something between maybe 300 million or 30 million or 20 million to 30 million and so on. So the computer is not so sure about it. Yeah. So if you have more data, more records to train the computer system can be more confident in answering our question. Okay. Okay, just to revise a little bit, how do we have a more accurate prediction? So if you start a big data project, yeah, if your prediction model is not so accurate, to increase the accuracy, these are the things that we can do. First is to have more data, as the previous slide show. You have more records. Yeah. Second thing is more variables. You have additional informations that previously not used for analysis. You can add it in the relevant informations. Yeah. So, for example, if let's say it's a land property, there are series of variables that is related. If let's say we are talking about apartment, then we have to look for different kind of criteria, because apartment, you don't talk about the land area anymore. There's no land area for individual. They talk about this, whether they have a cafeteria, they have swimming pool and all these things. Yeah. So different criteria, and people who buy the landed property, they probably want to be away from LRT, but people who buy apartment, they want to be near to LRT, you see. So they are contradicting kind of a preference that we have to take into consideration when we build a big data model. And of course, a very important thing is we have to choose the right prediction model. Okay. Okay, this is some sample data. Some data is not a straight line relationship. Some data, you plot it out, it looks like a curve. Yeah. So the first pictures I show the source of the data, plot it out without a prediction. It clearly that we cannot have a linear relationship. So the second pictures I show, the algorithm that draw a curve. Then there is a third and fourth. Yeah. So the fourth algorithm seems like feeding the data very well. But in fact, this fourth algorithm is not an ideal algorithm because it overfeed the data. That means it tried to fit very well to the informations, but in the future, it's going to be very difficult to generalize for other example. So overfeeding is just like when I go to the tailor and they make a clothes for me, and that clothes measure according to my body, my waist, my all the features of my body. That same clothes cannot be sold on the market because other people will not find it feeding. Yeah, so this is the overfeeding problem. This is another example I've tried before, building a solutions prediction for this dam level. So all these points are showing the data point, showing the dam level at a different day of the year. When we see the data, we incline to use a left-hand model that fit very well, but that doesn't generalize, and we found it not suitable. The right-hand side model seems to be more generalized and capable to do a better prediction. Okay, so there is two approach to the use case. So far, I've been discussing about the data-driven approach. Yeah, that is to look at our data and study it and see the correlation between the variables in our data, which variables is suitable to be used to create a model for the prediction. There is also another approach. Sometimes it's a preferred approach. Yeah, it's an ideation approach. Ideation approach is that the user will come up with the requirement of what they want. Then from there, we try to develop a prototype. And then after develop a prototype, we build the real model. From the requirement, we source out the data that is needed to build the prediction model. Yeah, but a lot of time we go to the organization, they do not know what they want. They do not know what big data model they want to produce. So end up, we have to start from what data you have, and then from there we figure out what model we can produce and whether those models make sense for the organization. So since this session is about use case, I talk about another use case. This one we have brainstormed with like a tourism of Malaysia, tourism board, about predicting number of visitors coming to Malaysia. So this is the objective. Yeah, this is the typical ideation. We talk about what we want, and then after that, we find out what information to fulfill the prediction learning. So the data that is needed to fit into this use case, first is the airline data, because airline can tell us how many visitors coming from which country or which city as well. So from there, we know exactly the confirmed people coming to the country. Of course, there will be cancellations, there will be a last minute booking and so on. But generally, we have the idea. Second thing is that the hotel booking. Yeah. So every hotel that is booking, we can see whether the booking is from overseas or local. From there, we can figure out. But another very important source, we discussed, is that a lot of people doesn't make the booking on a hotel. They book on Airbnb, and this Airbnb booking is something that we can't get the information because currently there's no law that require this Airbnb to be registered. Yeah. So what we can do is, in this situation, we have to do a web scraping to pull the information from the internet. Okay, and also there are other things like events. Yeah. Okay, this is just a use case approach on the ideation, where first we get a requirement, we do a design, we prepare the test data, we do exploratory data analysis to see the coloration of the data. Then we build the model, and then after that we test the model. If the model is not accurate, what we do is we'll go back to the design board and start again, and on what data is needed. The second approach is the data-driven. So what we do is we start with the data in the organization, we explore the data, then we design the use case. Then if we need to source for additional data, we'll do that. Then we build the model, and then after that, we validate the model. And then if, let's say, it's not ideal, we come back to the exploratory data analysis again to see what's wrong. Okay, so this is the two approach to build the use case. Okay, now it's more than 30 minutes. So we come to the Q&A session. Any questions?
Okay, ada soalan boleh post di ruangan Q&A ya. Okay, Mr. Thomas, kita ada one question from Wan Ashikin. Okay, the question is, to have accurate prediction, we need more historical data. So the question is, berapa past years data yang diperlukan untuk mendapatkan accurate prediction?
Okay, it's a bit difficult to answer these questions. Yeah, it depends. There are two areas. First is that if we already have millions of records, and if let's say we do the prediction and it already produce accurate prediction, the accuracy is high already, then it is already sufficient. Yeah. So sometimes we are not talking about how many years of the data, okay, unless we want to do a prediction based on the trend. If our prediction is time series based, that means the beginning of the year seems to be very low, in the middle of the year the demand is high, end of the year then it goes low again. So to see this trend, we need like 1 full year to see a trend. And to confirm this trend, if let's say I only have 1 year data, I can't very confidently say every year you also have the same trend, because it might be only happened last year that it has this trend. Yeah. So then I will need to have a few years to confirm that. Yeah. But otherwise, if let's say some of the property selling, yeah, the past year data may be less and less relevant. The most recent data is the most relevant one. Yeah. So if I have a lot of recent year data, it will be sufficient, because 10 years ago, the property price, it doesn't affect today's price. So it may not be important. So it depends. Yeah. So that's the first questions to answer.
Okay. The second question is from Cik Roshidi. Is non-linear graph cannot be used as results of the modeling?
Okay, what kind of statistics analysis of non-linear? Okay, we have this polynomial regression. Yeah, so some algorithms support polynomial that you can make the graph. Just now I have shared to show this polynomial. Okay, and some linear algorithm, if we don't have polynomial, for example, we want to find out about the build-up area, how it affects the price. We can actually manually create a field called build-up power to 2, build-up power to 3, that we manually create those prediction for this polynomial charting. That is a little bit technical. Yeah. If let's say you talk about other algorithm, is that K-enable, for example, K-enable algorithm, they can do very customized kind of a prediction. Another very good algorithm to use is the random forest. Random forest is very suitable, especially if you have things like, for example, different state, their behavior might be different. Landed property and this condominium, their algorithm, the behavior are all different. So random forest can deal with that very well. And for this kind of data, it can give a very good prediction. Okay.
Kita boleh ambil beberapa soalan lagi. Another 2 questions.
Yeah.
Is it okay, Mr.
Sure.
Thomas? Okay. Next, soalan seterusnya daripada Mr. Joseph. How much does it cost for a customized PDA model?
Okay. The main cost for a BDA can be from the data sourcing. Yeah. The data model is free. Yeah. It depends. If let's say you are using a Python model, it's free. If you buy a tools, yeah, depends on the vendor who sell the tools, how much will it cost. So if you are using an open source like Python, it can be free. But that is only the model. You want to train the model, you need the data, the relevant data. Some data may be readily available in your organization. Some data you need to purchase. As I just now talked about the airline data for tourism, you need to purchase from the airline those data. They don't give it to you free. Yeah. So there is a cost to it. For example, you want to analyze the trade data. The World Trade Organization also sells the data. You can buy those data to analyze. There is a cost with it. Yeah. If you want to do a prediction like a politician during the GE14, they're very popular. They will ask, I want to find out whether I can win the election. So you may have to conduct a survey to get the polling first before we can derive the model. So that cost for survey can be expensive. Yeah.
Okay, last question for this session for Mr. Azman Ta'am. Mr. Thomas just to ask, it is important to design a particular data model, example data warehouse, before we perform a big data process for data analysis.
Yeah, very good question, because later on I want to touch base in the second session about the enterprise data warehouse as well. Most of the time, we will encourage the development of the enterprise data warehouse because the big data, a lot of time is not just produce a model and that's it. Yeah, that will be too rigid of a solution. A lot of time we want to do the analysis, we want to do the presentation of this model and so on. So the best approach we will believe is to design an enterprise data warehouse where all the data we need, we pull and put it into the warehouse environment. Then we start to handle the big data. For example, this one of our customer, a hospital, they want to do embark on the big data project. They come up with 27 use case. So the first step that we do is now preparing the enterprise data warehouse to consolidate all the data within the hospital, all the different systems, put it into the warehouse, and all other informations that they believe is needed for the use case, they also put it into the warehouse. Because the different big data use case, they may overlap to use the same data. So when we have an enterprise data warehouse, it helps. Yeah.
So kita dah untuk for this first session kita akan soalan kita akan untuk for next session soalan yang tidak terjawab ni we can bring to another session untuk dijawab. So kita ada Mr. Thomas ada quiz kan?
Yeah.
Okay.
2 questions.
Kita akan ada soalan quiz dan pemenang kita akan beri hadiah lah. Okay. So tuan-tuan dan puan-puan kita akan tunjukkan soalan di skrin. Jadi siapa yang dapat menjawab soalan betul, yang pertama menjawab soalan yang betul, kita akan isytiharkan sebagai pemenang. Okay, so kita ada 2 soalan. Setiap soalan kita akan beri hadiah. Okay, boleh kita mula sekarang, Mr. Thomas?
Okay, the first question.
Okay, semua dah ready ya? Semua masih lagi mendaftar tu? Okay, sikit. Okay, oh dah ada jawapan.
Oh, since everybody know the answer, it's too easy. Okay. So the first questions, we have the winner. Should we go to the second question?
So the right answer is
it's overfeeding, yes. Because everybody seems to know it's overfeeding. Yeah.
Okay, that was the easy question. Okay, question number 2.
Okay.
Maybe you can wait.
Okay, the second question is which of the following is unlikely to contribute for the improvement on the model, to improve the accuracy of the model? Which of these are not important? Yeah. So there is 3 that is important and 1 is not. Yeah. So as you can see, more data for the learning, as mentioned earlier, more data, it will be more accurate, and more predictors, which is more columns, it will improve the accuracy as well. Then choosing the right prediction algorithm is also important. Yeah. For C, explanation on the prediction model, this is done after we build the model. So if a model already been built, then we start to explain what the model about. So that explanation doesn't help accuracy. So C is the answer.
Okay, kita ada pemenang untuk soalan 1 dan soalan 2. So, kita akan hubungi pemenang untuk dapatkan maklumat lanjut lah untuk kita bagi hadiah ya. Okey, untuk yang tidak sempat menjawab tak apa, kita still ada lagi quiz. So kita punya another 2 sessions. Jadi diharap menunggulah sehingga habis webinar kita ni ya. So yang masih ada masalah untuk pendaftaran boleh terus keep hantar message di chat WhatsApp chat, kita akan assist. So kita akan break 5 minit sebelum session yang kedua. Bolehlah kalau siapa nak pergi minum kopi ke apa kan. Mungkin tak sempat breakfast tadi sebab ada masalah nak mendaftar tadi. So kita we can start dalam pukul 10, 10:25. Okay. So kita break dulu, kita akan sambung semula pada pukul 10.25 pagi. Okey, kembali kita untuk sesi yang kedua. Saya harap masih ramai lagi yang bertahan nampak masih lagi nak mendaftar lagi. Okey, untuk pemenang kuis tadi kita dah hubungi pemenang kuis. Jadi tunggulah apa hadiah misteri yang kita akan hantar. Okey, untuk sesi yang kedua kita akan teruskan dengan topik easy implementation of big data. Okey, alhamdulillah Encik Azizuddin berjaya membuat pendaftaran. Okey. Okey, untuk sesi yang kedua, over to you Mr. Thomas for your next session.
Okay, thank you everybody. Thanks for still with us for this second session. First, I want to apologize for the first session has some misinformation. Yeah, I was feedback that this JPA is not the right name of the agency. Is the JPS that doing the prediction that they're more interested about the dam level. Yeah, and all this example, what I mentioned is not a current project. It's more of example of what government agency may be interested to do what kind of prediction. Yeah. Okay, so this second session, as I mentioned earlier, we will start with sharing of the screen first. Okay. Okay, we will use the live portal to showcase the big data. Okay, this is the tools. Yeah, actually I prepared earlier one version using Python and another version using the tools. Yeah, but seems like this Python is too technical, so we will not show. So in the future, if anybody interested more on the open source, we can have a different session to discuss. So for today, we talk about the property data. Just now I show on the PowerPoint, and how we can bring data from the source until we perform the analysis. Yeah. So first, I showcase the tools on how we load the data until we produce the analysis. So this is the tools. Yeah. That when I click, I can show you the data that I have loaded. So this is the data from all the different columns. And then the last column is the price, which is what we want to predict. Okay, so this is the data source, data set. Okay, the first things you have to do is to change all the data to be numerical, because we want to predict the number, price. So we cannot have, the algorithm doesn't allow to have like a yes, no, or a different category. So what we do is go through a process, what we call is an encoder, which is to convert all the numbers to digits, convert all the text to numbers. And then also all the now, we have to do some replacement. These are the things that we have to do under the data cleansing. Yeah. And the third step, what we'll do is to partition the data, split it into test and train. So to make it visualize, I add in a column at the end here. 0 is for the testing, and 1 is for the training. So we split the data. So you can see some is 0, 1, some is 1. I do that randomly so that it become a fair things. Yeah. If let's say we mark all the KL data, for example, as training and Selangor one as testing, then the model created only suitable for KL, for example, not for Selangor. So after we done this, normally what we do is we have a data exploration, a quick, simple one that I built. All these are actually behind is running Python. We integrate to Python, and then we run a coloration to see between the variables what is the coloration This is also what I've shown you all before. And then we can build some analysis, start from a simple regression analysis. So when we created the model, we can see the accuracy of the model. We can see the prediction line. Yeah. So these are a typical big data process from the data exploration all the way to build the model in the visual way. Okay. Okay, that is a visual representation. Yeah. So this is the actual environment where you can build a more complex algorithm. Over here, I select linear regression, and then I go to the data initialization. So this is where we can use SQL or different way of loading the data. Okay. Okay. After that, we can choose what price as a label. Label is what we want to predict the outcome. And then some of the field we don't want to predict, we just uncheck it. We don't want to use it as a predictor. I think it's the internet at work. Should we continue? Sorry, just interrupted for some technical connection. Okay, sorry for the interruption. Just now, the connection not very clear. Hopefully now it's better. Okay, just now we were talking about the price we choose as a label. So we want to predict the price. Yeah. And then there are two feature selection that we can see further between the features. Yeah. Then after that, we go to the model. We generated the model. This model, the accuracy is 79% accuracy. Yeah. So we can look at other things like the visualization. Okay, so this one basically just showcase the error and so on, diagnostic plot. And lastly, we can do a prediction. So you can enter all the figures. Let's say this property is 2,000 square feet. Barbecue, I just simply enter 1. Yeah. Okay, land area is 2,000. Okay, view up is 1,000. Okay, but this area is just 1. Okay, and run. Oops. Okay, this one I think I have to run the whole algorithm. So basically, if let's say you run the prediction, you can click here to run. Otherwise, you can also come into the environment here to do exploratory on the data. So this is typically what the tools that we want to use to do a prediction. Yeah. After we build the model, we can also look into the data in more visual format. Yeah. So just now what we've seen are the more technical. Let me try to use my. Okay, sorry, I interrupt for a while. Okay, apologize because some feedback that the screen resolution is not very clear. So probably due to the internet congestion. Okay, I hope you all can see this Google Map. Yeah. So here, what we're trying to show is the property show you on the Google Map. So you can select any location and you can zoom in. Yeah. So Google Map doesn't use the prediction model because we are not using the model to predict where is the location. The data itself already have. Yeah. To plot on the Google Map, you either have your data have the longitude and latitude, or otherwise, if let's say you have the jalan, in my data I don't have that. I just have the jalan and the area, and we can send to Google and they can resolve the address and display it on the map. So this is not about the big data, but again, these are the data in the warehouse that we can use it to display. So let's say I want to show on the Cyberjaya. Okay, this is all the data. You click at any point, you can zoom down to see the details. Okay. Okay, I show a few more analysis. So this another analysis here. I use a broader range of data. This data is not just Klang Valley, but other states as well. So I can zoom into a particular state. Let's say I choose to have Sabah and Sarawak. I don't know we have any attendees from Sabah, Sarawak. Let's look at Sabah, Sarawak. Okay, then these are all the cases in Sabah and Sarawak. Okay, and let's say we don't want to see Sabah, Sarawak now. We want to see the East Malaysia, like Pahang, Terengganu, and Kelantan. Yeah. Okay. Let's refresh. And you can zoom in the cases. Yeah. Okay. So you can add other filters and so on for the dashboards. So what I want to emphasize here is that besides building the big data model, a lot of time we want to have the other analysis. So this one, I load more data. Besides the residential, I have commercial, agriculture, industrial data as well, that we can plot the trend. Okay, this is another analysis going to show the different part of the this central region, Sabah, Sarawak. Yeah, southern area. Okay, let me close some of the screen. There's a lot of screens here. Okay, we need to pause for 5 minutes to solve some of the problem here, technical problem. Yeah. Okay, sorry about that. We do some fine tuning. Hopefully now the resolution will improve. Okay. Okay, let's continue. Beside those that I've shown you, also like to show you about some data that I received from INTAN that we can do some analysis. Yeah. So this data, millions of records, yeah, it's 1 million plus records, yeah. So you can scroll through. For the confidentiality, we don't show the name of the course and pengguna and the khusus, we don't show the detail, yeah. So this to keep the confidentiality. So you can see that this data, we only have 4 columns. So with 4 columns is very restricted. We can't do big data analytics. We need more information to be able to find the patterns. For example, which the users that like certain type of courses and so on. We want to do a prediction. Hopefully we have more columns of information. Yeah. But of course, this doesn't stop us from do the analysis. Even though we don't have the big data, we still can analyze the data. So we just built one dashboard, yeah. For example, here that you can select a year, or you can see the trend over the year and see how it's the performance. And over here is the course, the most registered course, the top 20 most people join on. So I can select the top 3. Yeah, and as I select the top 3, you can see that the right side, the pivot is filtered, yeah, where you can see who are the people who have joined these 3 courses. So let's say I want to take particular course, then now I narrow down to this course 275. Okay, so this is a sample of the analysis. So far, what I've shown here is the tools, yeah. The tools that you can do analysis, you can do prediction. Okay, come back to a PowerPoint. I just have 2 slides, yeah. What is the expectation for delivery of a big data project? Yeah, of course, first thing is the model itself. We have to build the model, otherwise it cannot be qualified as a big data project. But at the same time, we also must have the presentation with the explanation about the model. This is where just now I show you that we can see the accuracy of the model. For example, in the regression, we can even see the formula. The formula for the regression, we can explain what factors are more important, yeah, the accuracy and so on. So for unsupervised machine learning, we will talk more about unsupervised machine learning in our 3rd session today. where I will show you all unstructured data analytics. Yeah. So for unsupervised machine learning, sometimes we want to present the findings. Yeah. So for example, earlier I mentioned that you throw all the data and you try to segregate the customers, yeah, by the grouping. From there, we want to analyze every group of the data and see what is the characteristic. So another thing that we normally want to deliver is the model can be delivered in the PMML, the predictive modeling markup language, so that it can be transported to a different environment, if you want to call it. Or we produce an API that can be consumed by application that want to do the prediction. Yeah. So all this, if let's say we have an integration platform, this API will be made easy. And of course, beside all these things, as what I showed you earlier, we also come with analysis in charts or tabular format on the dashboard. Yeah. So the style is important. Yeah. What are style that you want to present? Some they use the portal-like kind of style, and some they like more structured dashboard kind of style. Later on, I will showcase a different style of dashboards. Yeah. Okay. Therefore, if let's say we want to deliver a big data project, I think the following components are also important beside the big data. First one is as the questions in the first session about the enterprise data warehouse. So I think it's important that we gather all the information put into the warehouse. Second is the intelligence, the analysis. Yeah, the intelligent analysis can be the business intelligence, can be a GIS system, can be a lot of other different form. Okay, then we have the portal or the dashboard to present it, and one of the very important component is also the integration platform with the ESB. ESB is the Enterprise Service Bus, where the big data modeling is always a back-end program. It's a back-end things, yeah. So the front end that want to build the interface to present in the web or in the mobile will, through the ESB, to consume the big data model. Okay. Okay, so this is my second session. We try to catch up in time since there's a lot of Q&A. So we open for question and answer. If there are more questions that want to look at the dashboard, we can go back to the dashboard as well. Okay, first question is like to ask whether can we apply machine learning on categorical data, both predictors and features are categorical. Okay, yeah, okay. There are different models to do a prediction on the categorical. Yeah, for example, yes, no answer. Yeah, whether classified questions is whether it's support questions, or if let's say it's a support questions, it's a change request or whatever in the help desk data warehouse. Yeah. So we in the third session later on I will showcase to you sentiment analysis. Sentiment analysis is one of the very good example of this categorical. Because based on the questions that type in, we will predict whether this is a positive sentiment or negative sentiment. So it's yes or no, good or bad, and all these things. So it's categorical. So yes, there are a list of algorithms that handle categorical. Yeah. Okay. Next question. We have dependent and independent variables. Okay, we model it to linear regression or non-linear regression. How to know which is the best model to use? Okay, okay. To know whether a model is good or not, we actually will build a model and then run through the training to train the model. And then after that, we use the test data to see the scoring. If the score is high, it's good. Yeah. So whether it's a linear regression or non-linear regression, sometimes it depends on the data. So if the data is more curving type, then is non-linear. Yeah. So we can build the algorithm to calculate and get the answer. Actually, I built some of the model actually for the price versus the build-up area, and I found out the build-up area. If let's say we use non-linear polynomial regression, we get slightly improved in the performance. Yeah. So we have to actually build the model and see the answer. Okay. Next questions. What is the difference? Okay. You can have a data warehouse. I normally you can have a small data lake for a project that you load whatever needed for that use case. Yeah. But a lot of time we encourage, if let's say your organization is going to build a lot of analysis and so on, we encourage enterprise level data warehouse. Yeah. So you pull a lot of data from all the different sources. It can be from external organization as well, that you pull the information inside to build an enterprise data warehouse for the entire organization. That means that is a single version of the truth for the entire organization. All the data you ever needed for reporting, for analysis, for big data is residing in that environment. So if you have an enterprise data warehouse, it probably can cater for more use of the organization instead of a very rigid kind of for one single use case. Okay. Next question. Which software is better to use? R programming or SPSS, etc. Okay. I'm from SpeedMiner, so if you ask me, I will sell you SpeedMiner, yeah. So, but you see, in the SpeedMiner, I did not show just now. Since you all talk about R, so you might like R. So just to showcase to you a little bit. Okay, we also integrate to R. I also like R, yeah. I like Python as well, yeah. I like R, I like Python, yeah. So what we do is Python and R, they have millions of developers that helping to improve the algorithm. So they are much faster than any organization. So if you hire 1,000 people to write a program, we still cannot beat them. So what we do is we take the approach that we generate the code in R. As R improve, we also get improved, yeah, algorithm. So yes, you can use R and so on to do a data warehouse, to do a big data prediction, perfectly fine. I myself like Python. Python is one of the most popular language in the world. But any other tools, you can also use them, because those tools require less technical knowledge. If I show you the Python code, actually yesterday we do a mock run, we show a Python code, so it's kind of scare a lot of people away. So today I'm not showing that. If you like Python, you are technical, go ahead to use Python or R. Another language you like to use is Scala. Scala with Spark is a good choice because you can analyze big data set without restriction. Yeah. So for SpeedMiner, we support the Python, Spark, R, all these things. Yeah. Okay.
Maybe we can take another one questions. From Roshidi, okay. What programming use? Okay, this one you answer already, right?
Okay, yeah.
First by speed minor.
Yes.
Okay. The top one.
Top one.
From Siti Diana Abdul Pujang. How to measure that our model is acceptable for prediction? How to verify it is a good model to choose?
Okay, I think a very direct answer to it is you look at the accuracy. Yeah. So if your accuracy is high enough, that might be a good model. But we also have to be very careful. That's where data scientists come in. Yeah. This is a very hard question to answer. Yeah. So, for example, because now we have a lot of COVID cases, yeah. So I use that as an example. If the government want to write a program, let's say all these symptoms and so on that we can tell a person is contracted COVID-19 disease, yeah. So I ask a series of questions. After you answer all the questions, I will predict whether you are committed COVID-19, yeah. So if we see that the percentage of population, let's say maybe only 0.05% or 0.5% of Malaysian, I think it's less than 0.5% of Malaysian contracted this COVID-19. So if I write a program that when you ask me the question, I always answer no, yeah, I get a very high accuracy. But this program is useless, yeah, because it doesn't value add. Another thing is that we also have to look at false positive and false negative. Yeah, false negative is when a person got COVID-19 and our test, our program say no, it can be dangerous because it can spread the virus around. Yeah, so it's rather that false positive, which a person don't have COVID-19, we say he has. Then we will do a more thorough test on the person. So that might not be so bad. So to evaluate a model, whether it's useful or not, there are many aspects we have to look at, and it depends on the use case. Yeah. Okay.
So soalan yang lain tu kita akan jawab untuk next session. Okay, kita akan ada quiz kan, Mr. Thomas?
Yes.
Okay. So this time around kita kena cepat lah. Semua kena bersedia untuk menjawab. Kita ada 2 soalan. Okay. Okay, sure. Okay. Soalan yang pertama.
Okay, so just now we look at the record pembelajaran data set. Yeah. So I did mention that we can use it for the analysis, yeah. But to do the big data modeling, there are something that we need to improve, yeah. So which one is the answer? So I see that most of you already answered, so I can just explain. First is more records, yeah. More records is always good, but this data set I mentioned that we already have millions of records, so it's not a problem, yeah. Second one is that I mentioned that it's only 4 columns of the data, so a little bit restrictive. If we have more columns, we can better explain about what we want to predict. So we need more columns, yeah, more variables. Yeah. The C and D, whether it's the name of the kursus or the code, is not so important. Yeah. We still can predict that. Yeah, so C and D is totally up. Yeah, A is not a big problem because we have sufficient data. So the answer is B. Okay, so we go to the next question. B, yeah. Okay, we found a winner for this question. So, and everyone is ready?
Okay, question number 2.
Okay, question number 2. You all saw that just now we plot data on the Google map. Yeah. So I did mention about what is the important things that we can have we need to have to plot on the Google Map. So which one of these is not important? Yeah. So the answer already answered by everyone. So the first one is important because if you have longitude and latitude, we can plot it on the map. If you don't have that, then if you have an unambiguous address, Google can resolve it and plot it on the map. Yeah, I did mention just now, emphasize a few times that we don't need a big data to plot on the Google Map. Yeah, you don't need a predictive model. So the answer is C. Okay.
Okay, so soalan saja untuk sesi yang kedua ni. Kita akan hubungi pemenang melalui Zoom chat ni untuk kita dapatkan maklumat. Okay, untuk ke sesi yang ketiga kita akan take a break untuk 5 minit. So kita akan sambung 11.05. Okay. So bolehlah siapa yang nak toilet break ke apa, kita akan start semula sesi ketiga 11.05 ya. Okay, kita berada pada session yang terakhir untuk session ketiga. Tajuknya ialah Unstructured Data Analytics. So, okay, over to you, Mr. Thomas.
Okay, thanks. Let me share my screen. Okay, I log into the system. So this time I use a different data set. This one is a healthcare database. It's a property. Yeah. So healthcare, you are done for a hospital. Yeah. I don't know whether I should name the hospital. We built something called case management. Okay. So this case management come with things that they can publish. Okay. The hospital, the doctor, after seeing the patients, they build the cases. Yeah. So they have this case that they can click to publish out their research and so on. So we have a structured way for them to enter the background, the result, conclusion, some attachment and so on. So automatically the system will publish it, become a nice auto that they can, for research purpose. So when a user, let's say a particular person look at a particular case, what we want to have is the support of the big data behind. Yeah, the unstructured data analytics will read every single words here, and then after that, build the knowledge, and then the system will show similar case to this. Okay, so there are other documents here that worthwhile reading because they have a similar concept. So if you click on it, then you can see the other cases. Okay. So you can see the other cases also have what similar, because this one is about stroke. So this is the topic that is more related, for example. Okay. So let me close this, come back to here. If you want to see how these things is being designed, there are a few cases, like for example, you can edit and see this is how it was entered, the attachment and so on to be a case. Yeah, and after that they publish it and become what I show you just now. So that is one of the example of a use case example of the unstructured data analytics. Yeah. Another example is the tweeters. Yeah, we link to tweeters, load all the tweets. Yeah, that we can do the trend. We can also have the word cloud. As I mentioned just now, you can see the positive and negative. And this is all we just load the data for the last few days, and we see these are the hot topics, yeah, that people discuss. Okay, so you click on the res key, and you can click and pop up what people talk about. Yeah, can open up and see what they speak. Yeah, this one don't have anything about positive, negative. This is my first time looking at this data as well. Yeah, so you can open up the tweets, yeah, and see what people talk. So some is positive, some is negative, and so on. So we can analyze and classify them, and you can see from the color here indicate whether it's positive or negative. Yeah. So if let's say you click on the plus sign here, you can actually analyze further on the topic. Yeah. So from the health minister, these are all the related topics on the health minister, you can see. Okay, so this is another area of unstructured data analytics. Basically, all the data in the system, we can feed it into the unstructured analytics to analyze, including, like for example, a medical case, we have a lot of things about the unstructured. Okay, So we have a lot of text, sometimes even the text to introduce about a particular person, yeah, particular doctor. So beside the unstructured analytics, a lot of time we will couple with other things like the analysis that will be interesting. Okay, as well as a listing of informations and so on. Yeah, so all these are what make a more complete solutions. Yeah, sometimes you can add those things that you can do a WhatsApp. You click on the phone, you can WhatsApp the person. And we also develop for hospital, for example, due to COVID cases, a lot of doctors, they don't see the patient in the ward all the time. So what we do is that we have a direct video conference call from the system as well. So all these are possible features of the system. Yeah. So so this is a typical kind of analysis we have on medical related kind of dashboards. Okay. And of course, beside this interface, this is more portal-like interface. Some may like to have a different look and feel where you can do all your analysis on the dashboard like this. Okay. So perfectly fine, depends on the preference. You can have a different style to present your data. Okay, so I'm told that today we have a lot of questions, so we cut short on the presentation. I've shown you the system, a very rough go through on this unstructured data analytics. So what I do is I have a few PowerPoint, and then after that we will open for the questions. Yeah. Okay, I just bring up one of the projects that we have done before with the Ministry of Higher Education. So we use the speak minor linguistic machine learning with the support of the natural language processing. So to understand the semantic relationship of the documents uploaded to the system, so that if let's say a particular document submitted, the system can see all the similar documents, and from there we can prevent the plagiarism. We also prevent giving too much a grant to a same area, for example. Yeah. So also we built the social network for communication between the researchers to share their opinion, their knowledge, and all this sharing and all this information is searchable in the system. Yeah, so these are different look and feel. Just now, I've shown you where you can see the similar cases on the case management. This is documents. We can also show the similarity, the percent of similarity, and system also can do a auto summarization on the documents. Yeah. So. This is about the sentiment model. If you like to, I can even type a sentence in the computer and see whether the computer is able to analyze positive or negative sentiment later on. Okay, SpeakMiner also have the search engine for the unstructured data analytics. So if you type the words data, they know that the information is data. Yeah, is related, so they search it up. Okay, the ranking doesn't mean you have data you show first and then information shows second. Is actually look at how the documents explain about this informations, and they auto summarize the documents to show it. Just like when you browse on the Google, you search on certain words, they auto summarize the information for you. So this is part of the big data. Okay. Other things on the unstructured data analytics is including further analysis of the words in the documents on how they're related to each other. Okay. So, okay, before the Q&A, just showcase one more things. Okay, sentiment analysis, yeah. Okay, here we type a sentence to say that all participant likes. I don't know whether you like it, but I assume yes. So if you type it, then the system can tag is positive. This is a negative one. Hopefully it's not true. Yeah. So frustrated, they can see it's negative and so on. Yeah. So this is to understand the human language to do a sentiment analysis. Okay. So okay, we come back to here. We open for the Q&A before we have the quiz. Okay. Social media account, Facebook set up as private. Okay. Is a web crawler managed to crawl the data? Okay, beside Facebook, yeah, just talk about the crawling of data first. In general, a lot of websites, they put a clause that even you manage to crawl it, yeah, it's illegal for you to crawl. Yeah, so they put a clause there that if you crawl their data, they can sue you. Yeah, so there is a legal implication on some of the websites. So that's the first thing. Second thing is that some of the websites with the security, crawler is something like it auto log into the system on behalf of the human and to do some work, and then whatever come back from the web browser, it can process it. Yeah. So some of the website, besides the Facebook and so on, some of the website you need to log in. Yeah, some they even make it difficult that when you log in, they have pictures and ask you to recognize which one is a traffic light, which one got car and all these things. So that make your crawler difficult. Yeah, unless you have a super intelligence crawler can do such a answer to it. So some of the things like Facebook, if you crawl, also the structure is different. It may changes and so on from the site to site. The best way to crawl a Facebook is you have the account. Okay, so if you can see it, your account probably can view the information. You can put it into the Facebook API and to crawl the data. So we have done some of this as well. But people who want the information from Facebook often not crawling on their own Facebook account. They want to see the public account. So these kind of things, you probably need to purchase the data. Facebook used to be easier, and recent years they start to become more and more strict that you cannot just easily crawl for the information. Okay, but Twitters and so on, you still can easily obtain the data without paying money. Okay, the next question. Oh, okay. I don't know about this voice to vec. Yeah, probably is to take the words to vec. Probably is convert the words to the vector. So if it is, then that's part of what a big data does. Yeah, it can convert all these vectors and to find the relationship between words. Yeah, but for SpeedMiner, the technology used is actually to understand the natural language processing, to go through the language path to understand and to the meaning behind. So the next question actually is quite related, is to ask whether we support the Bahasa Melayu. Yeah. So yeah, a lot of language model on the market. Are those English, even French, yeah, Japanese. Those are popular one that has been built that you can even go to open source and download those language model. But for Bahasa Melayu, I have not seen one. But that doesn't mean we cannot do unstructured analytics for Bahasa Melayu. So for Bahasa Melayu, what we can do is we use machine learning methods. Earlier in the first session, I did mention that we can send the program to the website to learn about Apple as a fruits, as opposed to Apple as the company or the computer. Yeah. So similarly, we can send all these sentence of Bahasa with a classification for the computer to learn. From there, then we can ask the computer to classify those sentence in Bahasa Melayu. Okay, so we have done some of these classification words based on the sentences with the hospital, where in the past, all these comment from the public manually analyzed by a person. So they will group them and say, okay, this is about the improvement for the ward. This is the improvement for the cafeteria, for the toilet, or whatever things. Yeah. So instead of people doing it, now after learning the past data, the computer can auto classify the information. Okay. Okay, the next question in SpeakMiner software, can we see the confusion matrix of the model training? Okay, yes. Just now when I show you the SpeakMiner, actually I'm using the Python program that I just built the day before. Yeah. So if any features that you do not see, you can actually add it in yourself, but the SpeakMiner already come with the features to handle all these confusion metrics. Yeah. Okay, next questions. How do you calculate coloration based on non-quantifiable parameters variables? Okay. Non-quantifiables, that means is like we have to quantify it. Yeah, we have to quantify no matter what. If you want to do a prediction, you want to analyze the things, you have to quantify the things. Yeah. So a lot of time from a sentence, whether good or bad, yeah, a person can and write the whole descriptions. We can use unstructured analytics. Yeah, or we can use all these unstructured analytics to convert the text to a scale of let's say 1 to 10, how good or how bad and all these things. Yeah. So we still have to find a way to convert them before we use it for the analytics. Yeah. Okay. And converting those things can be using a big data algorithm anyway. Okay. Next questions is. Okay, just now the one that I show is SpeakMiner. Yeah, so SpeakMiner I use two language. One is Python behind, and one is R. So we auto generate all these things and fetch the things to present. So, but if you are able to do it yourself, you can use the language like Python and so on to do it. The demo that I did just now is with a leap regression as well as another algorithm. I didn't mention it, but it's actually random forest. Yeah. So all these are algorithms that you can use to build model. Yeah. So if let's say at the end of this session, if let's say we still have time, I can showcase to you for those people who want technical. I have a Python program that can showcase how we build a model, and even a more complex cases where we build feature union to increase the accuracy. That's what the data scientists will normally do, which a lot of time if we just directly use the tools, they're just talking about a certain model, but a lot of time data scientists will want to mix multiple models together to do a final prediction. So if you have time and you're interested, we can look into that area. Okay, next question. What is the maximum amount of data to produce a more accurate prediction? There is no right answer to this. Yeah, as just now the first session I showed, the model are quite accurate in predicting those property below 5,000 square feet, because we have a lot of data there. The amount of data that I have actually is about 1,000 records, and that constitute to enough, because the patterns are very closely showing they are related. So, but for those data more than like 30,000 square feet and so on, we don't have enough the data on that area, so the prediction is not so accurate. So if let's say we build a same model, yeah, the prediction can be accurate on those data, those that is below certain number of square feet. The high number of square feet is not as accurate. It's possible. When we see the accuracy of the model, it will just tell you like 90% as an overall. Yeah, but when you dwell in, you can see that accuracy for less than 5,000 square feet is 99% accuracy. More than that is probably 50%. Yeah, so it is possible. Then they give you a mix of the accuracy. Okay, so the next question. Can you suggest alternative tools to produce a predictive model? You can use any of the tools, like just now some asked about SPSS, yeah, SAS, yeah. You can use SpeedMiner, yeah. SpeedMiner, some of the things we use R and Python, but for unstructured analytics, we use our own engine, yeah. Okay. What is the skill needed in order to understand each predictive ML models? Okay, the skill, best is go through a data science training. Yeah, so the programming for the big data can be easy. It's not very complicated, because a lot of data scientists may not be very strong in programming. So language like Python and so on are made easy. Yeah, tools like SpeedMiner will not require you to learn a computer language as well. But if you want to be very well versed to explain about the model, to know the different, the fine tuning and so on, you should go through a data science training. Data science training include statistics, yeah, and computer science, yeah. So you have to expose to those terms like what is a central limit theorem. You have to know about what is a normal distribution. You have to see how your data, if it is not normal distributed, you may want to apply the log on it, and to make the data more normal, and why is that so and so on. You will need to have all this knowledge to fine tune your thing. Yeah. Including, I mentioned to you, if I have time, I can showcase to you some program that we have to use something like feature unions and so on. So those things are not so common. If you do not go through a data science training, you may not be able to appreciate or understand it. Okay, so anybody want training, can check with INTAN. I think from time to time they have technical training as well. Okay, classroom training. Okay, next question. How many % of accuracy measure is acceptable? Yeah, so it varies. Yeah, some of the model you cannot achieve high accuracy. If let's say 60%, 70% is the best that the program can produce, as long as it's usable, it still helps us. It's good enough. And sometimes it's not necessary to be 100% accuracy. For example, we want to do a sentiment analysis. Some people will start to put in some comment, like if let's say I like Apple, they know it's positive. I don't dislike Apple. Yeah, I don't dislike except in whatever you can start to make things that is making trouble to the machine learning. But overall, there are some of the things that is positive that classify as negative. Yeah, and some negative that classify as positive. But overall, a lot of time, even like 60–70%, it might be useful enough. Yeah, so it depends. Okay, how to develop system integrate our model prediction using ML to visualize on the website. Okay, how to develop system integrate our model. Okay, the visualization of the model, okay, there's two parts. One is visualization of the accuracy about the error. Sometimes we want to visualize how the error, what we call the SSE, yeah, the error rate. Sometimes we want to visualize the model. If the model developed is for a simple regression, let's say single model, we show a straight line, like for example, just now I showed in the first presentation, where there's let me just bring it up. Yeah. Okay. Okay, so for example, this is a model that you can show the line representing the solutions. Yeah, but sometimes you have many dimensions you cannot show straight away, so you end up showing the coloration. You show each dimension, each predictor analysis instead. Yeah, not the entire model. If let's say you are using a decision tree, then we can draw out from the top how it branched, and then it branched out all the way to the left. Yeah. Okay. How many percent to split the test and training data? Okay. A lot of time I like to use a 60-40, 60% for test training and 40% for testing. Yeah. So sometimes people can change the percentage and test it out. Yeah. If let's say you don't really have enough data for training, you have no choice. You have to not sufficient data. You may have to put more into the training. But that risking that the testing part may be not as accurate. So the model tells to you is that we are 80% accuracy, but in the fact that it might not be 80% because you don't have enough testing data to really tell. Yeah, so it's important to have sufficient testing data. But if you don't have enough data for the training, so you have no choice sometimes. Yeah. Okay. Which error measure can best show the model performance? Yeah. Normally we look into the error rate. Yeah. Like the SSE. There is a model that let me show this model. Okay. 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 So let me see. I have the error rate here. Okay. There are various score here. Yeah. So a lot of time we just look at the variance score. From there, we tell the accuracy of the model. Yeah. You can see various error rate depends on the model, depends on what you want to predict as well. Okay, this one we look at it later. Okay, it's a complex model. Okay, next question. Speed minor is supervised and unsupervised or unsupervised. Yeah. Okay, speed minor support both. Yeah. Supervised, as I show you the model that we can do a prediction on the property. Yeah, that is a supervised learning. Unsupervised is the unstructured analytics. Yeah, so where there is no objective, we just let the system learn from all the articles that we throw in, and then the articles, if let's say you should search for certain things that you just try to figure out, Or if let's say you have one article, you just try to see what is the related articles. That is under the unsupervised learning. Okay, what model do you suggest is good? And you want to predict categorical, do we need to change all to numeric? If your data is categorical, yeah, if let's say you want to predict categorical, yeah, so categorical itself is not numerical already. So if you want to do a categorical kind of prediction, then you don't have to convert it to numeric. But if you want to do a regression kind of analysis on those, you want to predict on the numeric, then all your input fields, those predictors, you have to convert to a numeric. Okay. Last question. Okay. We have a lot of questions here. Okay. How to measure that our model is acceptable for prediction? How to verify it's a good model to choose? Okay.
Already answered.
Yeah, answered already. And how much time we still have? Because I can go into more detail about this question, last questions. Yeah.
Or how many?
Okay, we take a few minutes to go through something very technical. If those people are not technical, don't like technical, you rest for a few minutes. Yeah. So in this particular model, what I do is I actually import the data. Okay. I just do some sample of the data, and you can see there's a lot of columns of this data. Okay, so what I do is I have to convert all the data to numeric, because here is non-numeric. I want to predict the price, which is the numeric. So I run through this, yeah, and after I run through this, and I can write the data out now, and you can see that all become numeric. Yeah, so I convert all the text to numeric, and now I can start to build the model. So this is how I build the model. Okay, I actually normally data scientists will want to build the coloration to see what are the features that's more important. Okay, then I select the features that's more important. I start to build a model. So I'm not going to run the program for every one of it, because it may take a bit of time. So this for random forest I have run yesterday. I see the accuracy for this model is 75%. Then after that, I try to build a linear regression model. Linear regression will need the data to be more linear in relationship. So the algorithm is not so accurate. It's only 64%. Yeah. And then after that, I try to use a k-neighbor, and I get this accuracy even worse. Yeah. So the best model is random forest. Yeah. So, but instead of just 75%, I'm not happy about it. So what I do is I do a feature union. Yeah. So from the first model, the random forest, I do a prediction, and what I predict, I put into a new field called predict 1. The linear regression, I put into predict 2, and then the k-neighbor, I put into predict 3. And I analyze this again. Yeah. So when I analyze again this feature union, they combine all these, give a much better result, 88%. So when I analyze these three, also I add in a few more things here. What it means is that these three models have their strengths and weaknesses. Yeah. So I put in the factors like state, whether there is a land area or not, because no land area, that means it's condominium. Yeah. So some of the model may be better at predicting the condominium. Some is better at predicting the land property. So I mixing them again, I get a more accurate prediction value. Okay. So as you can see here, this is the answer, the actual price. This is the first algorithm to do a prediction. So prediction a lot of time is up, yeah. But you can see compared to the second and third model, the first model, which is the random forest, seems to be most accurate. So the feature union will consider all these three predictions and come up with a final prediction. Yeah. So you can see that the score is much better using this way, feature union. Then I'm still not happy enough. As a data scientist, we never happy enough until we find a very good score. So I further use another method of feature union. This time what I do is I split the land, those with land and without land, for each of these model first. Yeah, and then each of these I can see that the score already higher already. Yeah, okay. So after I do this, I do a final combination of everything, and I get the highest score, slightly better than earlier feature union. This is the final feature union that is a better score. Sorry, the label is a bit out. Yeah, so you can see that the process of the data science. Yeah. That we have to go through steps based on the data, based on the accuracy of the model. We may carry on to do other things so that we can have a very good result at the end. So this is where you hire a data scientist in those projects to fine-tune the things. Otherwise, you may end up getting of 67%, that's the best that we can have, and you just live happily with it. Whereas you can continue to do some work and obtain like 88% accuracy. Yeah. Okay. Sometimes you don't know what you miss because you don't know what's available. Yeah. So okay. Back to this PowerPoint. Any other question? Anything? Or we should go to the quiz.
To the quiz.
Yeah.
Quiz session.
Okay.
Harapnya semua bersedia.
Last two questions.
Okay, last two questions. Okay, first questions.
Okay, so which of the following is not part of the core text analytics feature? Yeah. So just now I've showcased the talk about the features of the text analytics. Yeah. So which one is not? I can see the answer already. So I explained. So document management is not core feature of text analytics, but document management can make use of the text analytics. Yeah, to improve. Document summarization, as I show you just now, we can auto summarize. Yeah, all the documents and so on, just like Google, it auto summarize some of the section. Document comparison sure is the features, as I mentioned, is prevent the plagiarism. We can compare documents and tell you what are the documents that are similar. The last one, intelligent search, when you key in the data and then you also search out the informations and then give auto summarize of the informations. And then if you notice on the right side, also we see what are the words that is commonly attached to it. So all these are using the text analytics feature. So A is the answer. Okay.
Yeah. Okay. Next question.
Okay, second question. Speed minor come with the support of supervised learning, unsupervised learning, or both. This one is the question that the audience just now has asked and answered here. Seems like everybody got it. So we have to end with a simple question, yeah. C. Answer is C, yeah, both.
Okay, kita dah dapat capture pemenang dia. Soalan 1 dan soalan 2 tadi. So kita akan private chat kepada peserta yang dapat jawab tadi untuk beri information yang kita minta, dan kita akan hantarkan, emailkan hadiahnya. Okay, so Mr. Thomas, finish already on your session. Okay.
Yeah, thanks everybody for your
okay.
attention.
So kalau kalau perlu hubungi pihak speak minor, mungkin boleh beri kita kontak, beri kontak kepada participants to email ke atau
Okay, this is my email address. Thomas@speakminor.com.
Okay, thomas@speakminor.com. So kalau tuan-tuan dan perempuan berminat dengan speak minor, boleh hubungi to email kepada Mr. Thomas.
Yeah, even want to call me also can, no problem.
So ini ialah mobile number Mr. Thomas. Okay, so kita telah tamat sesi webinar kita pada hari ini. Jadi pihak kami amat menghargai soalan-soalan yang telah dikemukakan dan juga penyertaan tuan-tuan dan perempuan yang aktif dalam ruangan chat tu. Dan juga mohon maaf kalau kita ada soalan yang kita tak dapat jawab. So kalau ada sebarang pertanyaan berkenaan speak minor, boleh hubungi terus dengan pihak syarikat speak minor Dan okay, kita nak buat promo sikit. Tadi Mr. Thomas ada mention INTAN juga ada buat kursus berkaitan data science. So kalau yang berminat boleh join kursus data science fundamentals yang INTAN anjurkan. Yang kita buat pada April dan Mei. So kalau berminat nak join kursus ni boleh tengok, boleh masuk kepada portal di Teams melalui portal INTAN. Okay. Dan lagi satu, kalau kita pun mohon maaf masalah teknikal untuk sistem pendaftaran, kita tak expect masalah ni akan berlaku pada hari ini. Dan saya nampak masih ada lagi yang minta bersedia daftarkan IC dalam sistem pendaftaran. So kita akan check, kita punya Zoom ni kita akan sampai pukul berapa kita boleh tunggu 12, okay? So siapa yang belum lagi pendaftar boleh masukkan di ruangan chat ni, beri IC kepada kita punya bersedia dan penghargaan juga kepada pihak speak minor atas persediaan memberi ceramah kita pada hari ini. Okey, lagi satu penilaian khusus, penilaian seminar memandangkan kita tak boleh nak akses sistem IEMG dan kita jangkakan dalam tempoh sejam kita dapat akses. Jadi tuan-tuan dan perempuan yang ingin mendapatkan slip kehadiran dan juga slide, kita kena buat penilaian seminar terlebih dahulu. Jadi ada partisipan yang raise hands tu. Ada yang raise hands tadi. Okay, saya tak pasti kenapa ada yang raise hand tu. Mungkin ada pertanyaan penting. Kalau ada pertanyaan yang penting boleh direct chat dengan bersedia dengan panelis tu. Kalau ada pertanyaan yang perlu amat perlu untuk ditanya. Okey, kalau tak ada apa-apa, untuk penilaian kan tuan-tuan dan perempuan perlu buat penilaian mungkin 12.30 sistem tu boleh berfungsi semula. So selepas buat penilaian baru kita akan tuan-tuan dan perempuan akan dapat slip kehadiran dan juga slide daripada slide untuk hari inilah. Okay. So from Mr. Thomas, any final words?
Yeah, also thanks everybody for your attendance. I also apologize some of the misinformation in the first slides. Yeah, just trying to give an example. And because also the questions has been overwhelming, so I try to answer as many as possible, as much as possible. So if any of the questions I did not fully answer, I apologize for that. Yeah. So thank you everybody, and thanks to INTAN as well organizing this webinar.
Untuk penilaian kita akan email juga kita akan email juga kepada peserta manual untuk membuat penilaian dan juga link penilaian. Okay, so itu saja dari pihak INTAN. Terima kasih.